let's hit up some the gist of what was in 1.4 and 1.6. We were, I don't know what today is. This is my last lecture number. Why don't I look at that? Since I number the damn things. Day 10. Fucking dead black man already. Straight out the gate. Well, lecture day 10. Who knows what day it is at this point? So in 1.4, you were looking at solving quadratic equations. And we had a couple approaches that we could use. Probably the easiest one was the zero product rule. If A times B equals 0, then either A equals 0 or B equals 0. This was good. This works great when you can factor. And I'm going to even go so far as to say factor easily. Because sometimes it can take a while to figure out what the factors are. For example, if we had x squared minus 6x, let's see, plus 8 equals 0. We have A times C equals 8, B equals negative 6. And so the two numbers, they need to both be negative, both be positive. In this case, B is negative, so they both need to be negative. So negative 1 and negative 8 don't work. Negative 2 and negative 4 do. Since there's no coefficient in front of x squared, we could immediately just take those negative 2 and negative 4 and plop them in right here. We did this factoring before, now we're just adding the equal 0 part. So we can set each one equal to 0. X minus 2 equals 0, or x minus 4 equals 0. We're doing that using this 0 property rule. This is like my A, and that's like my B from up above. So A times B equals 0, I make this A and this B, so I got that. And so the only way two things multiply together to get a 0, one of them has to be 0. There's no other possible fucking outcome, or they can both be 0. But in this case, it tells us, rather than having to guess and check which some numbers will give us 0, it gives us a means to find it. If we factor like that, we can just solve on each of them. Add 2 to both sides here. We learned how to solve linear equations. Add 4 to both sides here. I get x equals 4. X equals 2 or x equals 4. And you could check your work on both of them. You can and should if you're doing homework. Homework or a test. Check your work by substituting into the original equation. That's not where I want the parentheses. I want there. There we go. You can. All right. That not too bad. This one seems to be is the easy one. It's the even the quadratic formula is easy once you've memorized it. Let's take a look at quadratic formula. Any questions, Pedro?
No, not at all.
Okay. Did you watch the video for 1.4 and 1.6?
No, I was catching up on homework.
I'm guessing most people didn't. I might actually have to fucking lecture on that anyways. There's no point in continuing on if no one watched the damn video. Everybody's gonna get an F for not fucking following instructions. Alright. Option B. Using the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That is the quadratic formula. You can memorize this with flashcards and shit. This comes from a, b, and c come from ax squared plus bx plus c equals 0 gives you a, b, and c. So you need the equation to be set up to equal 0. Just like the zero property. The zero property one requires the right side to equal 0. Both the zero product, I didn't mention it or write it down on the last page, but it's pretty important. Both the zero product rule and the quadratic formula require the other side to equal 0. And so if the equation doesn't come that way, you have to make it that way first. Let's take a look at the one we just did. We had x squared minus 6x plus 8 equals 0. So, not much. How are you doing? I'm getting a fucking fist bump. What's this bullshit? No respect. What the fuck? Just had something in my eye. I didn't have to play. Fuck. So let's go back and let's look at this one again. We already showed using the zero product rule, we know the answer is x equals 2 or x equals 4. So I'm going to line this up with ax squared plus bx plus c equals 0. Which tells me for this equation, a equals what? 1. 1. Oh, look at Eric, just walking right in, fucking saying, I know this shit. I don't need your class doing. Did you watch the video?
Yeah.
Okay, well, at least one of you is.
I actually watched it during the time we're supposed to have class,
Awesome,
because if I don't,
it's easy to fucking put it off.
yeah, it is.
Alright, so we're gonna do the same thing on this one. We got the quadratic formula now though. So I've got these things, let's just plug them in. I'm gonna write down everything that doesn't have. I need to put it shit in, I'm putting in parentheses for everything. And I'm filling what I need. So the first thing you need is b is -6. That negative is different than the minus out front. So we gotta have both minuses there, and b goes here, that's -6 there. A is in the parentheses, there's a 1 there, and there's a 1 there. And C is that last number right there. Alright, so let's do some cleanup. That becomes a +6. Square roots are like exponents. Square root is a grouping term. Needs to happen first. So I did the -6 already, but before I do anything with this plus or minus, this everything in here needs to be resolved. So I have the square root, -6 squared is what?
36.
It's positive 36, the negative is inside the bracket. Minus 4 times 8 is 32. I guess I didn't need that much right there. What is 36 minus 32?
4.
4. So this is positive 6 plus or minus square root of 4 over 2. And what's the square root of 4?
2.
Plus or minus 2 over 2. So this gives us two answers. X equals 6 plus 2 over 2. Which is 8 over 2, which is 4. Or x equals 6 minus 2 over 2. Which is 4 over 2, which is 2. Which is the same answers we got from doing the zero product. If you have a quadratic formula, or quadratic function, quadratic functions are in this form. This bad boy right here is called a quadratic function. This always works. That zero product rule only really works if you can factor. This always works. Any questions, Drew? You look like you have questions.
I think I'm trying to figure out how to formulate them.
Were you okay with plugging everything in?
Yeah,
Alright,
okay.
there's a lot of shit going on.
Yeah, a little bit to process.
So take it slowly while you're doing it. It's so easy to fuck these up.
So that was all solving for X, right?
Yeah,
Okay.
notice we got 4 and 2, just like we had 4 and 2 from the zero product rule.
Mhm.
So it'll it's just another way of getting it, and this always works when factoring doesn't. Like if you can't figure out the factors, like if it's a fucking irrational number or and you have an ugly fraction you're not gonna fucking recognize right away. This always works. It works if they're complex numbers. Factoring will work with complex numbers too, but it's a little harder unless they're strictly imaginary numbers. Like doing, let's write this down. If we had x squared equals -36, which is the same thing as x squared plus 36 equals 0. This works well either way. I actually don't need to do anything, I can just take the square root here. And we get x equals plus or minus the square root of -36, which is 6i. You can do that here as well. But it's harder to see that this is x plus 6i, x minus 6i. It's harder to see. It's even worse when there's like something added to this in front. It's even harder to come up with like x. If it was x equals -2 plus or minus 6i, oh hell no. You're not factoring and getting that. Unless you're like magic. Like borderline impossible. Well, not with doing factoring. The next technique we're going to do, completing the square, we'll give you this also. This will give you this as well. The quadratic formula will get you these answers. -b plus or minus square root of b squared minus 4ac all over 2a. B squared minus 4ac is called the discriminant. Weird word. Don't know where it came from. Discriminant. But if that discriminant is greater than 0, then I have x equals -b plus or minus. This argument inside the radical is positive. I got plus or minus the square root of a real number. Well, not just the square root of a real number, a real number. When I take the square root of it, it's a real number. Over 2a, we get 2 real numbers. There are 2 real solutions. In fact, you don't even need to do the quadratic formula, you can always check to see what type of solutions you're gonna get, just by checking this. Because the one that's really handy to note is that if this is less than 0. Then I've got a negative number inside here, which leads to imaginary numbers. And it means X has two complex solutions. So if you do b squared minus 4ac without trying to factor and you see some shit like this, you see it gives you a negative number, don't try factor. If you do b squared minus 4ac, you're already halfway there doing the quadratic formula though, so you might as well finish, you know what I mean?
Yeah,
And if that equals 0. Flat out equals 0. Then x equals negative b plus or minus the square root of 0 over 2a. X is just one real solution. Negative b over 2a. Depending on how many people, depending on how many people did watch this video, we might be doing the full lecture on the sum base.
well,
But it's good for you, because the hardest one is the next thing. And unfortunately, completing the next thing, completing the square actually is more useful for other things. This stuff so far has only been good for solving quadratic equations, but completing the squares, you'll use it to help graph. You'll use it in a lot of ways. So we're gonna look at that in a second. Alright. Let's take a look at completing the square. I think this is easier just with the example. We've been doing x squared minus 6x plus 8 equals 0. Eric, you watched the video. Did I move the 8 to the other side? Like, did I move the constant to the other side?
equal and square, right?
Yeah, completing the square. Like debit card, I didn't write that shit down.
I don't see that.
Alright, well. I'm not gonna move it to the right side. One way is to move it to the right side. I'm gonna move the right side at the very end. Because this is a lot like doing f of x equals x squared minus 6x plus 8. And we would complete the square here to graph. As you'll see when we get to the next chapter. And I don't need to move it to the other side to do it, so. I'm not gonna move to the other side, I'm gonna watch what I'm gonna do though. The idea behind completing the square is. Let's take this part. And we wanna make this a perfect square. We wanna turn this into x something squared, that's the goal. And I'm gonna put the plus 8 to the side a little bit. Now, the way you go about completing the square is. Take this number and divide by 2. Which is b, divide b by 2. That goes in the parentheses. Then square. And both add and subtract. That value. -3 squared equals 9. So I'm going to add 9 and subtract 9. Pause, that's some shit going on right there. The reason why we add it and then subtract it is, if I put those together, I have effectively added 0. And adding 0 doesn't change the value. If Eric owes Drew $20 and Eric gives Drew $0, he still owes Drew $20. Doesn't change the value. So we took this number, cut it in half. And it's gonna go in here, and then we square it. And add and subtract it. This part right here is what makes the square. You can see if we multiply that back out. X minus 3 times x minus 3 is x squared minus 3x minus 3x plus 9. X squared minus 6x plus 9. That's where the idea of completing the square is. So this verified that I completed the square correctly. Then what I have left over is -9 plus 8. -9 plus 8 is -1. That equals 0 now. Getting it in this form makes it really easy to graph later on.
Divided the 6 by 2, correct?
6 by 2, the -6 by 2, yeah. through? Questions?
Um,
Cause you got that, I don't know what the fuck you're doing look on your face.
Mostly I'm just trying to focus. Government house classes are killing me right now.
That's. That's the stuck.
Yeah.
So we take the -6, we cut it in half. And that's what goes in this thing. And the way that just gives us the result of the parentheses. Completing the square though is we have to. Like what it means by complete the square, this is a squared term when we factor it. So complete the square, we are completing it by filling in that. And now rather than when I add 9 to the same side, I gotta subtract 9 to keep it balanced. We have x squared or x minus 3 squared. Minus 1 equals 0 right now. Now we solve like we're treating it like a square. I'm gonna add 1 to both sides. And I get x minus 3 squared equals 1. I take the square root of both sides. And I get x minus 3 equals plus or minus 1. Don't forget the plus or minus. And we add 3 to both sides. And I get x equals 3 plus or minus 1. 3 plus 1 is 4. 3 minus 1 is 2. And we knew 2 and 4 were the answers. It's important to note this method requires a to equal 1. Yeah. That's what that's a fucking disturbance in the force right there.
Books, pages.
Nice.
Cycling through the dictionary like.
Yeah.
They're rifling the pages. Have you guys ever ripped a phone book in half? Oh, it's fucking, ooh, it's fucking empowering. You're like, oh yeah, look at that. I can rip a phone book in half. You don't fucking believe me.
You gotta demonstrate that shit, yeah.
I'll see if I got an extra 1 at home.
There's a guy showed a YouTube video on how to do it.
Yeah, there's a secret to it. It's not brute strength.
Yeah.
No, ripping a fucking book in half without doing a secret. That's some fucking serious hand grip strength that most people, even fucking ripped people, don't have.
Yeah.
Very few people have that hand grip strength. To fucking rip a phone book in half, the non-cheat way.
No, a metal worker who can do it, but he's got grip strength like a black hole, so.
Right?
Yeah.
That's what it takes. Let's do another one of these, Cause this is a bitch, this one's much harder than the rest. So let's see, oh, fuck it, let's make it ugly. No, you want ugly, you want a fraction in it, or something that's gonna give a fraction?
I'm sure the homework will have it, so yeah.
Alright, let's do it. Let's do x squared plus 7 x, I don't know, minus 20. I have no idea what this answer is. I don't even know it has, I'm sure it's gonna be a decimal answer. We could do the quadratic formula and find out really quickly. In fact, we probably should check our work when we're done. So what I'm gonna do is I'm gonna peel off that negative 20 and put it to the side. And I'm gonna take this 7. And I'm gonna divide it by 2 and I get 7 over 2. I'm just gonna leave it at 7 over 2, fuck it. That's what's gonna go in the parentheses, 7 over 2. It's squared, and this sign tells me what sign goes there. Now I need to add 7 over 2 squared. Then subtract it. 7 over 2 squared is 49 over 4. So plus 49 over 4 minus 49 over 4. This part here is the parentheses. Alright, so I've got negative 49 over 4, and I've got negative 20. I can't really combine those as is, so I'm gonna take negative 20 and I'm gonna multiply it by 4 over 4. That way I can get a common denominator of 4. And negative 20 times 4 is negative 80. And if I add those two, I get negative 129 over 4. And I still have equals 0. Okay, does everyone? It's not the easiest thing, but does everyone follow what I did? I have no idea what the hell that was. So. Now I'm gonna add the 129 over 4 to both sides. And I get x plus 7 over 2 squared equals 129 over 4. I'm gonna take the square root of both sides. This will give us x plus 7 over 2. The right side I'm gonna write as the square root of 129 over the square root of 4. Because I know what the square root of 4 is, it's 2. Is 129 factor? 129 is 3 times 43. 43 is a prime number. There's no way to reduce the 129 to even a better radical. An easier radical. We're just fucking stuck with 129. So this equals plus or minus the square root of 129 over 2. And I'm making it very clear that the radical is only on the top of the fraction, not the bottom. Finally, subtract 7 over 2 from both sides. And I get x equals negative 7 over 2 plus or minus the square root of 129 over 2. And I'm going to write it as one fraction, just because I think this is what's going to fall out of the quadratic formula. But you don't have to write it as one fraction. I would say this is a good answer. Let's look at that with the quadratic formula. X equals negative b plus or minus b squared, square root of b squared, minus 4ac over 2a. A is 1, b is 7, c is negative 20. So let's plug that in. I'm going to write it with parentheses right now. And then fill those parentheses in. So my b goes in the top, first two parentheses on top. 7 and 7. A is that parentheses and that parentheses, and C is that parentheses. What the fuck's beeping at me? It's fucking with me. It's Discord. It's gotta be Discord. So the top, I've got negative 7, that's not changing. I've got the bottom, 2 times 1 is 2. I've got the square root, 7 squared is 49. And then I've got negative 4 times 1 is still negative 4. Negative 4 times negative 20 is plus 80. So if I finish combining them, I get x equals negative 7 plus or minus the square root of 129 over 2. Which is what we got from completing the square. But
This one seems a little faster.
it is faster. This one's well, cleaning the square's got more utility. Like if you're not looking for the solution, if you wanna graph it, the other one actually helps quite a bit, as you'll see when we start graphing. But. Alright. We're not gonna do it, I'm just gonna show you how to deal with it when A is not one for completing the square. Like, let's say we had 2x squared minus 16x. Plus, I don't know, 30. You can factor out the 2. By dividing everything by it. Then you complete the square in here. Leave the parentheses there though. Now, if you have it equal to 0, we could just divide by 2. For solutions, you can clear the 2. Clear the 2 by dividing. When we get to graphing, you need to leave the 2 in.